Hello, my name is Prabjot Singh, and I'm recording this session for displaying my descriptive and predictive modeling, which is a part of the discussion question 3. And so for this, as you can see on my screen, that we have to use one of the data to conduct the descriptive analysis. So this may include mean, median, mode, minimum, maximum, and other descriptive statistics that we have. And the same data that will be that has been used for the descriptive analysis will be used for the predictive analysis as well. And we have to conduct two of the predictive analysis using smart PLS, SPSS, or any statistical tool of our choice. So the statistical tool that I'll be using for this descriptive and predictive modeling will be SPSS. And the data that I'm going to use is the Titanic dataset. So this is SPSS. So first of all, I will import the data. So since it's the CSV data, so this is the Titanic dataset they have, and I'll just import it. So it takes a few seconds. Yeah, so now I'll press OK, and the data will be imported. So as you can see, the data has been imported. So first of all, we look for if there are any missing values in the data, and if it needs to be cleaned. So yes, so we have six um, columns. So the very first column is the passenger ID. So uh, that's basically um, the passenger ID gives information regarding um, the identification of different passengers. Then we have the passenger class. So in this we have three classes. It can be first class, it can be second class, or the third class. So which class, basically in which class were the passengers traveling? So then we have the sex. So here it's converted into a binary data where um, zero is for male and one is for female. And similarly, then we have age, so the age of different passengers, and then SIBSP. So this means the number of siblings and spouses that were traveling with the passengers. And the last column is survived. So it basically gives information regarding whether the person survived or not. So again, it is 0 and 1. So uh, these are the six columns that we have. So again, you can see that since the data does not contain any missing value, so it's appropriate to be used for this predictive and descriptive modeling. So there are some columns such as V1, V2. So these we need to get rid of these columns since these are of no use. So I'll just select. Okay, so I'll just select all of these. There's something wrong with it. Yeah, so I'll select all these. We want to be 13 and I'll cut it. And yeah, so this is the data that we have now. So first of all, we'll do the predictive modeling. And for predictive modeling, so for this, we'll go and analyze, and then the descriptive statistics. And in descriptive statistics, we'll choose frequencies. So yeah, so now we'll choose the variables that we want to choose. So since passenger ID, we don't want to get any descriptive statistics related to passenger ID, so we will not choose this. And then we we uh, we don't even need any information regarding the passenger class. So we will choose the variables that we want to, and we'll just um, move them like this using the arrow. So these are the four variables that I want to choose, for which I want to study the descriptive statistics. So I've chosen sex, age, sibling, spouses, and survived. So next, going to statistics. So since I want to know the mean, the median, the mode, and the sum, so I'll choose this. Then furthermore, I'll choose skewness and kurtosis and standard deviation, variance, minimum, and maximum. So we can choose more, but since I want to just go with this, so I'll choose these. Then going to charts. So I want to display the bar chart, so I'll choose bar charts. And in the format section, I just want it to be ordered by ascending value, so that's okay. So nothing to be changed in style and in bootstrap. So I'll just hit OK, and it will give me the output. See, so we can see the output that we have for the different frequencies. So this is basically the descriptive statistics for our data set. So as you can see here, so we have 891 values for each of the total data that we have. So we have 891 data points. So for the sex, and this is the mean for the different variables, and this is the median, and then mode, then standard deviation, variance, skewness. So I'll just highlight the ones that are a little that needs a little attention. So if I see, so since the kurtosis and skewness, so these are the two factors. So skewness is the degree at which the data is normally distributed, and it has a range of -3, threshold value of -3 to +3. So all other values are in this range except that for the siblings and spouses, we can see this is the only value of skewness that is outside the range of -3 and +3, which is 3.695. So this means that the data is positively skewed. So this value it infers that the data we have for the sibling and spouses is um, positively skewed, and most of the data points are on the left side of the distribution. So we can say that the distribution is not normally distributed. So the data is not normally distributed. So it is positively skewed. So similarly, for kurtosis, which is the measure of how heavy-tailed or light-tailed the data is relative to the normal distribution, and the threshold value for kurtosis is -10 to +10. So similarly for kurtosis, that has a threshold of -10 to +10. So we can see that for sex, age, and survive, for these three variables, uh, we have the values of kurtosis which are in the range of -10 to +10, except for sibling spouses again, for which the value of kurtosis is 17.880. So what does this mean? So the value of 17.880 means that there are more data points that are further away from me, indicating that there's a greater variability. So we can also say that it has positive excess kurtosis and the data is heavy-tailed. So except for sibling spouses, all the other three variables are normally distributed, and the the data for sibling spouses is positively skewed, and it is something away from the normal distribution that we have. So apart from this, we also have the individual statistics for each of the parameters. So we can see that for sex, the males, the number of males is 577, that is 64.8%, and number of females is 35.2. Then for age, we have the same statistics for different ages. Then similarly for siblings and spouses, the number for zero sibling spouses 1, 2, 3, 4, 5, and 8. So this is what we have. Similarly, we have for survived, and we can also look at it using this bar graph. So in the sex, we can see that most of the passengers were male, since it's almost double of the number of females. Then in the age, we can see that the so most of the people were of the age group around 30 years. So that is what we can infer from this. And similarly, most of the passengers were traveling without siblings and spouses, since we have more than 600 passengers who have zero siblings and spouses, and the number goes on decreasing. And for the survived, so we have more people who survived, who did not survive than who survived. So we can, if zero means not survived and one means survived. So this is the predictive statistics. We got to we got to know about the mean, the median, the mode, the variance, and similarly the kurtosis, skewness, so all these things. So now we will shift on to the second part of this assignment, that is predictive modeling. Predictive modeling is. So for predictive modeling, I'll perform two techniques. So the very first one is linear regression. So for this, sorry, for this, what we will do is that we'll go to analyze, and then we'll go to regression, and this is the linear regression. So linear regression basically is a study of how the two variables are related to each other. So how we can predict so what's the probability of predicting a variable based on another independent variable? So suppose I have to choose one dependent variable and independent variable. So for this, I'll choose age as a dependent variable, and whether or not the person survived, I'll choose it as independent variable. So this means that we want to predict the passenger's age based on whether they survived or they did not survive. So from the statistics, I'll choose estimates, I choose confidence intervals, model fit, R-squared change, and can so descriptives, as we have already done, so we don't need to. I chose this, so continue. Then we can also choose the plots if you want. The standardized residual plots. So I'll rather skip this. Then for this, from this part, I'll choose the standardized predicted values, the standardized residuals, and that's it. And I'll go with the same for options for style and bootstrap, and I'll press OK. So once this is the results that I have got for the linear regression. So we had a dependent variable named age and an independent variable called survive. So the first part shows the model summary. So here we can see that the R square value. So the R square value. So basically, R square value is it measures the goodness of fit of a model. So if R square is 1 plus 1, so that indicates that the regression line fits with the data perfectly. So since here, the R square value is very low, it's 0.005. So this means that the model does not explain much about the variability. So it's a very poor fit. So we can say that only 0.5% of the variation in age can be explained by passengers who survive. So there's little to no correlation. So it's not a good predictor. So we can say that age is not a good predictor. Um, so, sorry, the survived number of passengers who survived, so that is not a good predictor. So further, so these are the coefficients that we have. The unstandardized, the coefficient standard error, the significance level. So this is we have the residual statistics. So this is what we have for the linear regression. So similarly, we can try to do the linear regression choosing other variables. So I'll do one more. So again, go to analyze regression, and then go to linear regression. So this time I'll choose my dependent variable is going to be the same, that is age, but my independent variable this time I'll rather choose passengers class. So everything else will remain the same. So everything else will remain the same, and I'll hit OK. So this time you can see that the R square value is 0.109. So it's somewhat better than what we got for survived as an independent variable, but still it's very low. So 0.109, it is better than what we have than what we got previously, but still the value is very low. So we still will say that even in this case, again, the model does not explain much about the variability, and it's poor fit. So there is little to no correlation between the two factors that we have selected. Now, the other predictive modeling, the second predictive modeling technique that I would perform will be logistic regression. So I'll go to analyze, go to regression, and I'll do the binary logistic. So the binary logistic regression is basically to model how these variables influence the likelihood of dependent variables. So suppose I choose a dependent variable called survived, because survived is a binary variable. So it's either 0 or it's 1. So I'll choose survived as a dependent variable, and then I'll choose the independent variables. My independent variables will be passenger class, sex, age, and sibling spouses. So these are my independent variables. So I want to model that how these independent variables influence the likelihood of survival. So this is basically the logistic regression will help me in interpreting. So the categorical variables, so since there are no categorical variables, so we'll skip this. Then for the save, I'll choose probabilities, then I'll choose group membership, and then I'll also choose standardized residues. So that's it. Here, I can choose classification plots, Horsemirror and true goodness of fit, correlation of estimates, confidence interval will be 95%, and that is it. Nothing to be changed in style, and nothing to be changed in bootstrap. So we'll not perform the bootstrapping, so let's continue without it. And with this, we'll press OK. So this is the results that we have got for the logistic regression. So the logistic regression case processing summary shows that there are 891 data sets which are included in analysis, and there are 0 missing cases. So there are no missing cases here. So the dependent variable has two values. It's either 0 or it's 1. So this is the classification table that we have got here. So classification table is basically, it's trying to tell us that how it's trying to tell us that how correctly it has been able to predict the model has been able to predict the data. So for this is the classification table, and then we'll further go to omnibus test of model coefficients. So the omnibus test, it assesses the overall model fit and significance of the predictors in logistic regression model. So in this case, it indicates that the logistic regression model is statistically significant. So as you can see here in this omnibus test, it shows that the model is statistically significant. This means that at least one of the independent variables. So we had about 4 independent variables, that is passenger class, sex, age, and sibling spouses. So at least one of the independent variables has a significant relationship with the dependent variable that is survived. So as we can see that the chi-square statistic is 395.860. So this is used to test the hypothesis. So suppose we have a null hypothesis. So our null hypothesis is that that there is no effect of predictors. So there is no effect of the independent variables on the survived class. So whether the passenger survived or whether the passenger did not survive. So there is no effect of either of the 4 predictors on our dependent variable. So this is our null hypothesis. But our alternate hypothesis will be that there is a significant effect of one of the predictors on the independent variables. It can be any of those. So we have a significance level. So the significance level here is less than 0.001. So since the p-value is less than alpha, So we can say, so since as the p-value is very low, so we can say that we can reject the null hypothesis. So the null hypothesis was that there is no um, effect of the predictors. So we will reject it. That means that that we have that we will stick to the alternate hypothesis that yes, there is one of the predictors that has an effect the on the dependent variable, that is survive. So now we will look forward to which is that variable. So that relationship between the predictor and that dependent variable, it can be positive or it can be negative. So we will further look for it moving forward. So again, we again have this classification table here. So this classification table, as you can see, so um, so these are the predicted values, and these are the observed values. So if the predicted and the observed are same, so then we say that the model is able to, and then we can say that um uh, if the percentage correct is high, so then we say that our model is a good model. So suppose so we have 0 and 1. So if we say that 0 is not survived, so the model predicted that it did not survive. So this is what it's saying, that it did not survive. It predicted it, and that is the one that we observed here. So if the observed and the predicted are same, as in this case, so this is also 0 and this is also 0. So we have 458 values here. Uh, and in the second column, this one. So this one shows that the model predicted it to survive, but in actual, it was observed that it did not survive. So that is 91. So these are the values. These are basically the values that the model could not predict effectively. So similarly here, so the model predicted that it survived, but it was observed. It was observed that um, so the model predicted that it did not survive, and it was observed that they survived. So these ones are 98. So basically, what we have to look for is these two values. So this shows that the model predicted did not survive, and it was observed that the passengers did not survive. So that is 458. So that we can also call it as true negatives. And this is what we call as true positives. So the predicted is same as the observed. So 244 values, which is of the predicted and the observed, are the same. And 458 values that they did not survive, they are the same. So the percentage correct here is 83.4%. So how will we calculate this? So this will be calculated as 458 divided by 458 plus 91. Similarly, this 71.3 is calculated as 244 divided by 244 plus 98. So we have the overall percentage of 78.8%. So this means that the model is able to predict 78.8% of the values correctly. So this is what this classification table tells. So basically, we have to look for the true positives and the true negatives. Next important information that we get is from this correlation matrix. So this will basically tell that how the the independent variables and the dependent variables. So constant here is basically our dependent variable, And these are the 4 independent variables that we chose. So now, as we were able to reject the null hypothesis that there is no uh, effect of predictors on the dependent variable, so now we will try to see that how exactly are the 2 variables correlated with each other. So as you can see from this correlation matrix, so for the constant and for the predicted class, so for this, as you can see here, that the value is the correlation between uh, survived and P class is minus 0.805. So this means that there is a strong negative correlation. So there is a strong negative correlation between survived and the passenger class. So we can, in this context of the Titanic data set, it suggests that a higher passenger class is associated with a higher likelihood of survival, and a lower passenger class is associated with a lower likelihood of survival. So that is expected, as higher class passengers might have been given priority during the evacuation. So higher the class, more are the chances of survival. So then we have, for the sex, the correlation between the survived and the sex is 0.068, which shows that the relationship between these two is very low. It has somewhat positive correlation, but that correlation is very low. So it shows that whether the person is male or female, it did not exactly had a much effect on their survival rate. Then if we see the age, so age similarly has uh, strong correlation, that is negative 0.808. So this again shows a strong negative. It suggests that lesser the age, more the chances of survival. So the younger passengers were more likely to survive, while older passengers were less likely to survive. And in the last one, that is sibling spouses, again we have a negative correlation, although the correlation is not that strong as it is for the passengers class and the age, but still it is somewhat negatively correlated, and the factor is of 0.243. So this suggests that having more siblings, so having more siblings or spouses on board is associated with lower likelihood of survival. So more the number of spouses, lesser is the likelihood of getting of survival. So what can we imply from this? So we can say that the passengers traveling with more family members might have had more difficulty during evacuating. So that can be one of the reasons why having more siblings um, ultimately led to lesser chances of survival. So although the factor is not that strong, but still there is some correlation between the two. So this is all that I had for this session. So we did the predictive modeling and the descriptive modeling. For the predictive modeling, we did linear regression and the binary logistic regression. These are the 2 techniques that we have studied. So that's all, and thank you so much. I hope you like my video, and if you have any comments, please feel free to reach out. Thank you so much.